Assalamualaikum warahmatullahi wabarakatuh, and a very good day. My name is Muhammad Fadli bin Azmee. My metric card number is 181091287. Okay, today I'm going to do a video presentation about a three-phase voltage Y to Y connection. Okay, first I will go through about the content of this video presentation. The first content is introduction and objective. The second content is methodology. The third is finding and discussion. And lastly, conclusion. Okay. Introduction. Three-phase generator consists of three single-phase generator with voltage in the same magnitude but has different phase angle by 120 degree from each other. As you can see here, the black colored line is the phase 1, the red colored is phase 2, the blue colored is phase 3. As you can see, it's shifted by 120 from each phase, but each phase has same magnitude. Okay. There are two configurations of three-phase system. The first configuration is Y connection, and the second configuration, project that have been assigned for this semester is I'm going to study about three-phase Y to Y connected generator. Next is the parameter of the Y to Y connection. The first parameter is the load of the Y to Y connection is balanced. The next parameter is the voltage. The voltage that has been assigned to is 275 kilovolt. And the load and the transmission loss that will be assigned is according to my metric card number, which is the load is 81 plus 8J ohm, while the transmission loss is 87 plus 12J ohm. The next parameter is according to the electricity supply application handbook, or we call ESA version 3. The acceptance of the power lagging is 0.9, while the frequency, the value frequency that accepted by the TMB is 50 Hz. Next is objective. Okay, the objective of this video of this project, the objective of this project is to familiarize with voltage and current characteristic of three-phase generator. Okay, the objective also to construct the three-phase Y to Y generator with balanced resistance and reactance respectively. Okay, the third objective is to evaluate the transmission and load impedance, current, voltage, and accepted voltage drop. The next objective is to evaluate and analyze the active power absorbed by the load by using the 2 wattmeter method and the conventional measuring method. Okay, the objective of this video presentation also is to study the power factor and frequency value according to electricity supply application book. Okay, so by study the power factor and the frequency, we know about the accepted value which has been applied in our country. Okay. Okay, next is methodology. Okay, as you can see here, the first step of the flowchart is start, and next step is the parameter that I just mentioned earlier. We have to set up the parameter. Okay, by having our parameter set, we can calculate the phase voltage. As you can see here, the formula of phase voltage is V line over square root of 3. And since the load is balanced, so the Z1, Z2 and Z3 is the same, while the neutral current is 0. So the next step is we have to calculate the IAN, IBN, ICN. IAN, IBN and ICN is represent phase cut. Okay. The next step of the flowchart is to find the value of V load and voltage drop. Okay, next, calculate the active power absorbed by the load by using the two method, which is two wattmeter method and the conventional measuring method. After that, we want to verify the calculation. We have to construct the three-phase Y2Y generator connection using PSEM software. Next, run the simulation and record the result. And after getting the result, we have to make a discussion and lastly make a conclusion. And we are already okay. Next, this is our project circuit. As you can see here, this is the circuit diagram. Okay, the next part is finding and discussion. We will go to finding first. Okay, this is the result of the calculation value and the measured value. Calculated value is the value that has been obtained through calculation, while the measured value is the value that's obtained from the simulation. Okay, to calculate the V line, this is how the formula. V line equals to IAN Z1. IAN is phase current. So this is how the phase current that obtained from the calculation, and this is how the reactant, and we get this result, this value. Okay. The calculated value, all the same. I have stated in the slide. Yeah. But the calculation value and the measured value are not the same. As you can see here, this is 76.425 kilovolt, while the measured value for VAB is 78.315 kilovolt. and VBC also didn't have the same value, and the VCA also does not have the same value between calculated and measurement and measured value. Okay. So we go to the voltage drop. Okay, to calculate the voltage drop, the formula is here, but the voltage drop is too big, 51.8. This is I get to calculation. Okay, next we are going to the current value of the calculated and the measured. As you can see here, the calculated value and the measured value also did not have the same value. To get the value here, I use the formula of IAN equals to VAN over Z total. So I got the value. As you can see here, the IAN, IBN, and ICN has the same magnitude, which is 937.75. Okay, next, power. Okay, this is the next studies of the active power. This is the first method, which is conventional method. Okay. Okay, as you can see here, this is the value of this is the value that we get earlier. Okay, the RMS value. Okay, this is the power, the active power that we got for each. Okay. Okay, this is a power for A. This is power for B. This is power for C. Okay. Okay. The calculated value of the active power that I got through calculation is 214.98 megawatt. To get the measured value, we have to plus all the power A, power B, power C. Then we got the P total. As you can see here, the value of calculated and measured is slightly different by -2, as you can see here. Okay. Okay, next is active power. To find the active power through 2-watt meter method. Okay, this is the formula. It is the same formula like the conventional method. So the calculated value will also the same, 214.98 megawatt. Okay, so this is the measurement that I get from the simulation. Okay, we have to plus both. Okay, and this is the P total of the active power of the simulation. As you can see here, this is the both value has exactly the same as the conventional method. Both methods get the same value. The calculated also the same, the measured value also the same. But between both calculated and measured value are slightly different. Okay, discussion. What I get in this video, in this simulation, is line current and phase current are the same. So it supports the theory studies and the experimental or practical studies. Okay, the value of the calculation and measurement are not the same. For voltage and current. Okay, but active power is slightly different. Okay, so regardless, either we using the conventional method or the two-watt method, it will not get the same value. Okay, lastly, conclusion. The conclusion is, I have learned the acceptance value of power factor and frequency. The power factor test. Okay, lastly, conclusion. The conclusion is, I have learned the acceptance value of power factor and frequency. The power factor of my kind of voltage main is 0.9, while frequency that has been stated in the handbook is 50 Hz. In addition, I have learned how to calculate voltage, current, and active power through calculation. So by doing the calculation, I already know how to calculate the steps to get the right value. Okay, third, I also learned how to construct circuit of 3-phase Y-to-Y generator using this PSIM software. This software is new to me, but eventually I started to get used to it, because before this we using the lab in the third point for my conclusion is, I can construct circuit of 3-phase Y-to-Y generator using PSIM software. Next, I also learned how to record the value from the simulation. I learned how to calculate the RMS value, how to make a graph from the circuit, and from the circuit I can get the RMS value. After the third point for the third point for conclusion is, I can construct circuit of 3-phase Y-to-Y generator using PSIM software. Next, I also learned how to record the value from the simulation. My third point of conclusion is, I can construct circuit of 3-phase Y-to-Y generator using PSIM software. Next, I also learned how to record the value from the simulation. From the simulation, I can record the value of voltage, the current, and also the active power. In addition, I also study to do analysis of the circuit from the voltage line and active power. I have to compare the conclusion. I have to compare the calculation with measured value. And lastly, from this project, I familiar with the wire-to-wire connection operation. So that's it for me. So thank you for so that's it for me. Thank you for watching my video. I hope I will that's it for me. That's it for me. That's it for me. I hope that's it for me. Okay, that's all. Okay, that's all for me. So I hope you enjoy watching my video presentation, and goodbye. Okay, that's it for me. I hope you enjoy watching my video. Bye.